Which one of the following two compounds has the stronger IMF and therefore the higher boiling point? So in this particular question, the two choices, and again, there's 10 of these. This is really an important part of this, so you're going to be doing a lot of this. We'll review at least a couple of these. So MgS, magnesium sulfide, or MgCl2, magnesium chloride. Our process for this will be the following. So first, well here, I'll go over the process. First, decide if it's LDF, dipole-dipole, H bonding, or ion-ion. And so whichever one of these is farther to the right is going to be the stronger IMF. However, you can get questions in which they're both ion-ion, and you have to then identify the trend in ion-ion forces. And that's what we're going to do for number one. So our first thought is both of these have metals in them. Both of these have ion-ion forces. And if they both have ion-ion forces, then you have to talk about the trends. And there are two trends in ion-ion forces. The first and most important, so two trends. One, the first and most important is, and I'll just write most important actually first, is the product, or product of charges. So the larger product of charges and what I mean by that is if we look inside magnesium sulfide, we can see that magnesium is a 2+ ion, sulfide is a 2- ion. The product of those is 2 times -2, which is -4. So right here I'm doing product of charges. That says product of charges. Sorry, I lost it in there. Magnesium chloride is, magnesium is still +2, chloride is -1. You only do the charge for one ion, even though there are two total. But this is 2+ and just minus or -1. So 2 times -1 is -2. So the larger product of charges has stronger ion-ion forces. And so our answer is magnesium sulfide. Any questions about that? Okay. Well, then let's tackle question 2 in this. Question 2, we're going to be comparing sodium chloride with methanol. Sodium chloride has as its strongest IMF ion-ion forces. And I'm just going to write ion-ion. And if you were to draw the Lewis structure, or if you were to just note that it's an alcohol, you would see that this has hydrogen bonding. And the molar masses, while not the same, are pretty close to each other. So we know that as you go to the right, you get stronger IMF. So the answer must be sodium chloride. Let's come on down. Actually, I was going to do number 4, but I don't know. Let's look for another one. Here's a good one. Good old number 10. Number 10 has the same question, but different compounds. And Br2, if we draw its Lewis structure, or if we just think about it, we see that there are only two atoms, that these two atoms have the same electronegativity and therefore have the delta En is 0. However, you come to the fact this is non-polar molecule. And then you'll come to the same conclusion about I2. It is also a non-polar molecule. And for two non-polar molecules, both of them will have as their strongest IMF LDF. And the only way to differentiate these is the fact that as molar mass increases, LDF increases. And so you would look up the molar mass, you would see that iodine has more molar mass, or a higher molar mass. I'm not sure which is a better way to say it. Probably higher molar mass. And you would have to circle iodine. And if I come back to the first sheet for this question, which is somewhere around here. What did I do? Oh, yeah. So remember, now we know that there are two of these. You can have both of them being LDF, and whichever one has the higher or more molar mass is the one that has the stronger IMF. And then you can also have two ions, and whichever one has the larger product of charges is the one that you choose. But you will never have two dipole-dipoles or two hydrogen bonding, because that gets a little too crazy. Anyway, so that's, let's see, I think is there anything else? All right, so I think there is one other thing I want to go over, and that's going to be, we'll call it question 11. Question 11 goes like this. Let's say you have the same question, but your two molecules have skeletal structures like this: 1, 2, 3, 4, 5, 6, and 1, 2, 3, 1, 2, 3, 4, 5, 6. And the question is, which of these two has the stronger IMF and therefore the higher boiling point? Well, your process for this one goes, first off, these are both carbon and hydrogen containing compounds. So one. Both only contain carbon and hydrogen. And of course, in skeletal structures, we're not showing the hydrogens, but they're there. So both have LDF as their dominant IMF. Two, if they have both LDF, then the next thing you look at, look at molar mass. The one that has more or higher molar mass, just like the example we just did, will have the stronger IMF and be the one that you choose. But if you then look at the molar masses, you'll see that both of these have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 carbons. Both of these have the same molar mass. And so then you move on to 3. And you only move on to 3 only if the molar mass is the same. Then the more spread out molecule, or the molecule with the larger surface area. And so I think I'm going to write it as the more spread out molecule has larger IMF. And here's what I mean by more spread out. If this molecule is trying to interact with another of the same molecule, we could put that other molecule here. And you can see that there's a large surface area, that this molecule is more spread out and can have larger interactions with a neighboring molecule than this one. This one, if it had a neighboring one, would only be able to interact, well, let's just say not as long, or in a narrower, which color? There we go. So the surface area, or the amount of interaction between these two, is smaller. The surface area here, so larger area of contact, larger IMF. Larger area of contact. Larger IMF. And you'll see on the recitation today, one of the questions has 2 molecules with the same molar mass, and then we are going to have to go and look at how spread out each of them is. The more spread out. And these are real effects, by the way. We talked about these real effects in the lecture outlines. It leads to real differences in physical properties, real differences in boiling points, which, anyway, so these are none of this. So this stuff and the ability to differentiate, meaning tell apart, intermolecular forces is one of the most important things in this class. It's why lubricants are lubricants, and if you look at the intermolecular properties, there's a lot to say that comes down to chemical structure. Yeah. Anyway, I think that's all I wanted to say about that one.